Hi guys, welcome back to my YouTube channel, Let's Crack Real Math. My name is Viraaj, and in this video we'll be looking at trigonometry of non-right angled triangles. So we will be having a look at the sine and cosine rules and also a different way of finding an area of the triangle. So before we get started, please perform an LSS, that is like, share and subscribe. Also, please make sure that our calculator is in degrees mode. If you don't know how to do it, all you have to do is press shift, then mode, and then 30, which is represented by DEG, which stands for degrees. This can be done on a Casio scientific calculator. So without wasting much time, let's get started. So before we go into examples, let's see what exactly I mean by non-right angled triangle. We know that a right angled triangle, let's just change colors. Okay, that's better. We know that a right angled triangle looks something like this with a right angle. But a non-right angled triangle would look something like this per se. It's not the best drawing, but it is a rough sketch. You can see that none of the angles are at right angles and they all are probably of different values. Now, the best way to start solving this is by labeling it. What I mean is, if I were to draw something like this now, like that, and something like this, and something like this, let's get rid of this. Right. I have an angle here, I have an angle here, and I have an angle here, which I do not know the magnitude of. I have one length of the side here, I have one length of the side here, and I have one length of the side here, which I do not know as well. Of course, in the questions that we will be doing and in the questions that do set an example, we will have some of the information, if not all. But to start with, let's label it. Let's label this diagram. Let's say this point here, this vertex or vertex is A, this vertex is B, and this vertex is C. Now, the opposite side of that vertex or that angle, we can label it with the small letter. For example, if this side is A, then the opposite side over here will be small a. If this side is B, then the opposite side over here can be small b. And if this side is C, then the opposite side over here can be small c. It may look complicated at first, but this is probably the best way about going to solve this question. Now, usually they would give you a few of the information. Like for example, let's say this angle over here, this is 23 degrees. This length of A over here is 7. The small c over here is 6.5. And they've told us to find this angle over here. Now, in order to do this, you would need to use a formula. And the formula that you would use in this case, or the formula that you will use in general is small a over sine a equals small b over sine b equals small c over sine big C. Now, as you can see, I've equated it 3 times. That means the formula could be these two, the formula could be these two, or the formula could be A over sine A equals to C over sine C, any of the 3. In this case, we have our big A, that is the angle, sine 23, and the small a, that is the magnitude over here, to be 7. And since we're trying to find the big C, this big C over here, we also have its corresponding small c, which is 6.5. So putting that together, we would have something like this. Oops, sorry. Microsoft whiteboard just acting up a bit here. Okay. Okay. Right, so small a, that's 7 over sine a, sine capital A, which is 23, equals to small c, which in this case is 6.5, over sine big C, which is what we're trying to find. Now, in order to solve this, you may use algebra knowledge, and you know that we would cross multiply. So 6.5 times sine 23, that would give you 2.54 to 2 decimal places. That's equal to 7 into sine C. Then sine C is 2.54 divided by 7. That's 0.36 to 2 decimal places. And then C is the sine inverse of 0.36. Sorry, and that is C is equal to sine inverse of 0.36, which is 21.1. So eventually your answer over here would be 21.1. Now, it may not look correct due to the drawing. You might be saying, oh, it should be around 60 or 70 degrees, but remember that all these type of questions are usually never to scale in exams. That's what they're trying to find all the time. This brings that we also have 2 more formulas to note. One of them is a squared equals to b squared plus c squared minus 2bc cos A. Note that the 2bc and the cos A are being multiplied together. And the other formula we have is cos A equals to b squared plus c squared minus a squared over 2bc. Now, if you look carefully, you can see that for the second equation, we've basically just made cos A the subject of the formula from here. So if you take this and this to the other side, they eventually become minus, and they divide themselves by this minus, eventually becoming plus, and the A turning out to be minus. The reason we need to know these 2 formulas is sometimes this formula over here, the A over sine A equals to B over sine B equals C over sine C, may not work all the time. Sometimes you're not looking for an angle, sometimes you're looking for the side, or even if you're looking for the angle, you don't have the adequate information to use that formula. And that's why then you have these 2 formulas, and from these 2 formulas, you need to know which one to use. So in all, these 2 formulas are known as the cosine rule, and you could say that because there is cos in it, and you may figure out this one, this formula over here is known as the sine rule. Not sin, sine. Now, let's move on to the first example we have. Right. So, this question requires us to find the length of AC. Now, let's label this first. We have A here, B, A over here, B over here, and C over here. So that means our small a is somewhere here, our small b is here, and our small c is here. Even though they said AB is 4.2, I know that actually it's small c, which is 4.2. Sorry, let's just write that again. Small c, 4.2. Okay, now we need to see which formula to use. In this case, since we are trying to find the length of AC, which is the small b, we need to know the angle of this B over here. Now it may look tricky at first because we don't know the angle, but think about this. We know that in a triangle, the sum of all angles equal to 180. And we know the two other angles, 37.6 and 72.2. So all we can do over here is just do 180 minus 72.2 plus 37.6. Sorry, plus 37.6. This becomes 180 minus 72.2 plus 37.6. That's 109.8. And doing that, you get 70.2 degrees. So basically, this is our big B. Our big B is 70.2. Now that we have our big B, we need to find our small b. And note that we have our big C as well as our small c. So all we can do is we can do b, small b, over sine b equals small c over sine c. Note that whenever you do use sine, of course, it is always the bigger letter that comes, meaning always the angle and never the length of the side. So, doing this, our small b is what we're looking for. Our sine b, we just found out as 70.2, equals to our small c, which is 4.2, sorry. Yep, our small c is 4.2, all over our sine big C, which is 72.2. Okay, so cross multiplying this, we have 4.2 times sine 70.2. That is 3.951699 equals to b into sine 72.2. Now you may be wondering why I use such a long number. It's because the longer it is, the more accurate it tends to be in terms of decimals, and since we are working and we are not at the final answer, we're still in process, so it's most likely that we should use bigger numbers. Of course, your final answer can be rounded off to the required amount of accuracy. That might be 3 significant figures, or 2 decimal place, or 3 decimal place. So now to find b, you can do b is 3.951699 all over sine 72.2. And then you have b, putting down your calculator, 3.951699 divided by sine 72.2. That should give you 4.15 units to 2 decimal places. The units is the required measurement. I'm not sure if there was measurement in the question. There's no centimeter, there's no nothing, so but if there is, please make sure you put that in, as you could lose marks for that. That's the answer to that question. Moving on to the next example. Let's zoom in. Right, now here we need to find the length of AC. So again, let's bisect this. Let's label it in our own fashion. We have big A over here, so our small a is over here. We have our big C over here, so we have our small c over here. We have our big B over here, so we have our small b over here. Now, if you look carefully, you can't use the sine rule because you don't have two corresponding degrees and the size of the length. What I mean is that yes, you do have 67.5 and the length of the side you're trying to find, but you don't have the angle for any other. You don't know these angles, and if you don't know 2 of the angles out of 3 and you're trying to find the length of something, then automatically the sine rule goes out of the equation. Now we have the cosine rule and we have two of them. Since we are trying to find the length, we can use the cosine rule. A squared equals to b squared plus c squared minus 2bc cos A. Now obviously we're trying to find small b, so we can just rewrite this formula. Instead of a squared, just say b squared is equal to a squared plus c squared minus 2ac cos b. As you can see, it may look like I've changed the formula, but I haven't. It's just that since we're finding b squared and not a squared, I've just changed every place there was b squared with a, basically. Now we can input our values. So we know that small a squared is 10. That's 10 squared. Okay, let's just rewrite that. 10 squared plus small c, which is 8.8, so 8.8 squared minus 2 into 10 and then into 8.8, and then all of that into cos big B, which we have at 67.5. Now please, when you are putting this in the calculator, sometimes the calculator might function it wrong because maybe your brackets are in the wrong place or for whatever reason, because it has happened a few times to me. So what I tend to do is I do the calculation of this side first and then this side and then subtract this by this. So let's do 10 squared plus 8.8 squared first. That gives 177.44 minus, so 2 times 10 times 8.8 times cos 67.5. This gives minus 67.35284. Further calculation, this gives 177.44 minus 67.35284. This gives 110.08087716. Of course, it is b squared over here all the times. And now that you have this, in order to find your b, you just have to take the square root of 110.087716. This is, putting this in my calculator, 100.087716. This is 10.50 units to 2 decimal places. That is your final answer. Again, please note that 67.352284 and then all of this, I'm just doing this to improve the accuracy, because the more decimal places you use during the process, the better it is and improves the accuracy of your final answer. So moving on to the next example. Over here they're asking for the size of angle A, so we're trying to find big A. So let's start labeling this. We have small a over here, this is our big B, so our small b is here, this is our big C, so we have a small c over here. Now again, we can't use the sine rule because essentially we don't have any of the angles, so we can't use that. So we go with the cosine rule. Now which one? Since we're trying to find an angle in this case rather than the length of the side, we can use the formula cos A equals to b squared plus c squared minus a squared all over 2bc. Now we don't need to rearrange this formula again because we are essentially looking for big A. So let's substitute the values into this equation. We have cos A equals to b squared, our small b squared is 20.7 squared, plus small c squared, that's 11.6 squared, minus our small a squared, that's minus 13.7. Yeah, sorry, so right, 20.7 squared plus 11.6 squared minus 13.7 squared all over 2 into our small b, which is 20.7, into our small c, which is 11.6. So simplifying this, we have cos A is equal to, using a calculator, 20.7 squared plus 11.6 squared minus 13.7 squared. This gives you, 20.7 squared plus squared. Yep, this gives 375.36. Please be careful while entering your values in the calculator. Sometimes we do mistype and that can lead to a calamity, so please be careful when you are typing. All over 2 times 20.7 times 11.6, that is 480.24. And to find A, you can simply take the cos inverse of this. So A becomes cos inverse of 375.36 over 480.24. Finally, A is, putting that in your calculator, make sure you are in degrees, 36 over 480.24. This gives you 38.59 degrees to 2 decimal places. And that is your final answer for that question. And moving on to the final example for this topic. Here. So in this question, it asks us to find the area of the triangle. So no need for sine or cosine rule. Now we're all familiar with the area of a triangle. We know area of a triangle is equal to half times height times base, or height times base over 2. It's the same thing, these two. But in this case, you can see we do not have the height, we do not have the base. So how exactly are we meant to go about this? The answer is that there is a formula especially for these type of triangles, and the formula is equal to half AB sine C, where C is the angle that they give, and A and B are respectively the sides right next to that angle connecting that angle. So this eventually becomes half into 12.5 times 9.9 times sine of 139.9. Note that if I did half times 9.9 and then times that by 12.5 and then times that, it's still the same thing. A times B times C. If that were to give you 30, C times A times B would still give you 30, no matter the order. So, moving on, putting this in your calculator, you have half times 12.5 times 9.9 times sine 139.9. This is 39.86 degrees to 2 decimal places. And that is the answer to that question as well. So thank you for watching this video, guys. Please do not forget to perform an LSS, like, share and subscribe, and thank you for watching. Have a nice one, guys. See you soon.